This illustration deals with other conductors in the raceway or cable of the service in accordance with NEC 230.7. Now let's review this illustration, and let's start at the weather head. Now notice we have the service conductors coming in, and of course the grounding conductor or binding jumpers in 230.7, exception 1. We've already talked about the meter base in 230.66. It's not considered service equipment. We haven't talked about the weatherhead yet, but we will in 230.54 coming up. But notice we could pull with those service conductors control circuit conductors for some means. Say we had a kilowatt meter, but we wanted to pull those control conductors in. This would be permissible. Now we would have to apply the derating factors if we had 4 or more current carrying conductors by 310.15 C1, and if we were routing it through a higher temperature than 86 degrees Fahrenheit, the correction factors of 310.15 B1 had to be applied. Now many times students of the code want to know, well, where is this information about adjustment factors and correction factors and temperature and all this? Where can I actually read this and get a grip on it so I actually know I can refer people to it? Well, just go to your table 310.16. Read the information above the table. Now, I believe in the 2020 code, that's about page 161 is where you can pick up your table 310.16 right in that area. And at the very top of the table, you'll have bold-face typing print that states you're allowed 3 current conductors in a raceway or cable or direct buried in the earth that are routed through an ambient temperature of 86 degrees Fahrenheit or less. Now, many times engineers and electricians will say, now we have a 100-foot run of conduit and conductors. I'll take 10% of that by the code, which we're going to get into and look at, and 10% of 100 foot, I would allow 10 foot to be routed through a higher temperature than 86 degrees Fahrenheit and still get the benefit of the 86 degrees Fahrenheit and the ampacity of the tables currents that are listed in table 310.16 if I should have 3 or less current carrying conductors in the raceway. Then the adjustment factors of table 310.15 C1 would not be applicable. So this is where you find the information. And then the other information that we get into with the 10% rule and all that, we'll get into all that in great detail in chapter 8, which we'll be looking at. But the main thing with our work of the Stalkup's Electrical Design book, you can choose any chapter you want and review it so that you're up on what's required, because you're designing, installing according to what each chapter that you want to review has the information that you need based upon the NEC as well as other codes and standards that's very pertinent to maybe your design and your installation. So figure 6-9 deals where it's permitted to have other conductors in a raceway or cable as long as you meet 230.7 of the NEC. Now, the next thing before closing out this illustration I'll review with you, notice the terminal ratings. We would go to 110.14C and 110.14C1 and 110.14C2, and basically those devices are 100 amps or less or over 100 amps. So you can say, yeah, the main's over 100 amps. So that would be a 75-degree terminal automatically by the review of 110.14C. Now you can say, well, the ones below it, though, are 100 amps or less, and we're just saying that. then they would be 60 degrees C terminals. With that, you check those breaker terminals, and they were 60/75 degrees terminations rated, or 75 degrees C rated. And then, of course, we know in 70B, maintenance standard, we would look at 15.1.3, and we would check the insulation terminating to each breaker, and we would check that insulation, see that it had a slow melt, baked out, black looking, so hot it's trying to separate from the copper or the aluminum. Is the terminal overheated, that where it was, say, a golden looking copper or brass, it was turning different colors from the heat? We're required to review this as maintenance electricians. So when we're installing new, then we have rules that we have to apply as installers so that the system will operate without any of these problems developing. So there is quite a bit of responsibility to design and install electrical systems in accordance with the NEC and other codes and standards.